I'm here today to talk about automated machine learning and our journey at 8451 Kroger to use of automated machine learning. So what is Kroger? For those of you who aren't aware, and many of you probably aren't because it's a US-based grocer, we're quite a large business. We're the third largest overall retailer in the world, even though we're focused entirely on the US market. And we're the second largest grocer in the world. So it puts us in the Fortune 20. Last year, we generated $120 billion in revenues, $5 billion of which came from digital operations. 8451 is Kroger's data and science company. So we leverage Kroger's data, vast data, to provide better customer experiences to Kroger shoppers. So our data that we have is largely from our customer loyalty program, and we have a lot of it. We have over 10 petabytes of data. That's over 3 billion shopping baskets that we've analyzed. And to put it in perspective, 10 petabytes, it's a hard number to digest. So one way to think about it is if you encoded the DNA of everybody in Europe, North America, and China, 10 petabytes would be about the storage you need to keep all of that. All right? So we know our customers. So at 8451, as I said, we're Kroger's data and science company. We're about 1,000 employees strong now, a little over, about 250 of which are data scientists. And our data scientists use this Kroger data to affect decisions throughout the entire store. Just a flavor of some of the work that we do at 8451. We affect Kroger's customer strategy, item assortment, site location and store formats, how we cross-sell, pricing optimization, relevant customer communications, which would include direct-to-customer marketing, meaningful promotions, and our loyalty program. And again, this is really just scratching the surface of the type of work that we do. So my team is called Enable the Science, which is a bit of a unique title, I know. We are responsible for enabling, empowering, and encouraging the rest of the organization to use machine learning efficiently and effectively. And so when we talk about enable, to us that means selecting and using appropriate technologies, including machine learning technologies to improve our science. And for us, empowerment is curating and preparing and providing training and best practices to best use those technologies in the company. And then finally, encouragement is the exciting part of what we do. We get involved in cutting-edge use cases to carve out new capabilities to make available to the rest of the organization and to evangelize the use of those technologies. So the Enable the Science team that I lead is responsible for what we call our machine learning toolkit, which enables our data scientists to build predictive models and to do other data science activities. Our toolkit includes many fairly commonly known open source packages. When we first constructed it back in 2006, we examined the state of the marketplace for automated machine learning. And back in 2016, we kicked the tires on several dozen companies that claimed to automate some aspect of building machine learning-based models. And during that time, unfortunately, the companies that we looked at were relatively immature. Many of the offerings were fairly thinly developed or too narrowly focused to be of much interest to the work that we were doing. The one exception for us was a company that we found called DataRobot. And so DataRobot met our fairly rigorous criteria. If you get a chance to talk to any of our DataRobot people, I think our criteria maybe are kind of legendary there now. I mean, we had a pretty tough rubric for them to go through. But they did meet our criteria, and so we moved to a POC back in 2016 and took our time, figured out that it made sense for us, and grew from there, our relationship. And today, we make DataRobot available to all of our data scientists as one of our toolkit tools. Before I talk about the benefits of DataRobot, I need to provide some context about data science in general, at least how we do it. So the prototypical data scientist, some of you may have seen something similar to this, really has to be expert in 4 knowledge domains: math and statistics. That's table stakes. Usually they come from quantitative, highly quantitative fields. Data science methods knowledge. So it's not enough to know math and stats. You need to know how to use advanced algorithms. Some of them are implemented in various types of languages. Each of them has its own set of nuances and details to truly understand. Domain expertise. So this is knowing the value stream of your organization. And this is often the most challenging part of the learning curve for data scientists. It can take years in some organizations where the value streams are complex for somebody to really obtain an understanding that can be useful in domain knowledge. And then hacking skills. So data scientists are typically expected to have skills in coding languages like R and Python, used to be SAS, and SQL and others. So you can imagine that, given this set of criteria, that space in the middle is fairly rare, hallowed ground, and so few people actually truly sit in that space that we consider them unicorns, right? And so how do we go about operating in this space where you're looking for unicorns, and how does automated machine learning help? But before I get to the answer there, I want to dispel a relevant myth, at least in terms of the way we practice at Kroger in 8451. So I should say this may not be true for all businesses, but for us, I want you to consider a very gifted humanities grad, maybe somebody who came from down the road at Cambridge or Oxford. It's a talented individual, and imagine you train them up on LexisNexis and Google. And LexisNexis, if you don't know it, is you can think about it as a search engine for legal precedents. Right? So you train them up on these technologies. Would you then expect them to be a litigator? Right? Would you want them handling your company's litigation? I hope not. Right? So comparable, or an analog to that, is if you take a skilled business analyst that doesn't have those domains, those 4 domains locked down that I talked about, and you train them up on an automated technology, you really can't expect them to be a unicorn. They're not going to be a data scientist. That doesn't mean they can't have value for you. It just means you need to be cognizant of the fact that data scientists have specialized skill kits that go beyond what automation can help with today. Having said that, how does automation really help? So for us, it's mostly about efficiency. So it is, in our estimation, the current state of automation for tools like DataRobot is like giving an existing driver a much cooler and much faster car, right? They're going to get where they're going much quicker, and they're going to want to do it more frequently. And that's really at the heart of how we get value with DataRobot. So I'm going to dive in a bit further. Automation is reducing the burden on data scientists in 2 of the 4 domains that I talked about. The scope of data science methods knowledge continues to expand. So hopefully some of you have been exposed to terms like deep learning, neural networks. All of these technologies just continue to emerge. Generative adversarial networks is a great one if you haven't gotten to that yet. So this space just evolves, and it's going to grow broader, and I think the speed of that evolution is actually still increasing. So as this space increases, and we have a higher burden on our data scientists to understand these methodologies, tools like DataRobot really come in to help us cut through this diagram and to give us the ability to empower our data scientists with these advanced methodologies by relieving some of the need for them to understand the methods in detail and reducing some of the understanding that's required at the mathematical or foundational level to use those algorithms efficiently. And that's very valuable, very valuable. So I don't want to dismiss that as not important. So when we talk about this powerful new technology, the challenge many companies are going to face is how do we effectively embed this technology and use this capability to drive value? And history provides some lessons. So for a minute, I want you to imagine that you're a factory leader back in the 1880s when electricity was the emerging technology of the day. And the incumbent technology for factories was steam power. Right? So the framework for steam power was very centralized. A large steam engine powered by coal would spin a central shaft, which would then in turn span ancillary shafts and belts throughout the company. But it was that one central drive shaft that was critical to the whole operation. By the mid-1880s, electricity could be used in a similar way to the steam engine. You could simply replace the steam engine with very large electric motors to turn that central shaft and keep your operations going as they were. And for about 30 years, that was the choice that factory owners faced. I'm going to spin my central shaft, I'm going to do it with steam, or I'm going to do it with electricity. And we think now, electricity, wow, that's amazing technology, it must have just dominated, right? After 30 years of electricity being available, it had claimed about 5% of the market share, right? So what happened? What happened is innovators finally understood that true innovation requires changing the value stream fundamentally to align to the technology. And so innovation allowed for using electric motors in a decentralized ways to spin up little production lines all over the company. And that ended up being much more efficient, but it also had all kinds of other benefits that weren't necessarily foreseen immediately, which would be much cleaner, much safer, much more pleasant environment. You could put people out the windows. You could spin these things down, and the centralized system had to spin 24/7 for any work to be done. It had to be moving all the time. So once the innovation took hold, steam was dead, right? That 95% share was gone nearly instantly. For interest of time, I'm going to skip over this a bit, but in the 1980s, we had somewhat of a similar situation with personal computers. All right, personal computer technologies took hold, and they showed up in businesses throughout the globe, but it really took years for innovation to allow for those technologies to be used appropriately to drive productivity. Now, before I go there, let me step back a second and just say that the key lesson here is that real change is in how we organize our value chain to align to the best capabilities of our technology. And it's not easy. Okay. So who wins in this future? Well, the winners will be the companies that do fundamentally adapt their talent strategy, their core value processes, and their culture to leverage this new technology efficiently. And so, as an example, at 8451, we've stopped pursuing unicorns. We know that's futile. And instead, we understand and truly truly look for diversity to build collaborative teams of data scientists that, as a collective group, is capable of covering the entire ground that we need for use cases to be successful. Further, we pull those teams together and give them a great deal of autonomy and allow them to help us understand which technologies are really necessary to support their particular use cases. And that includes understanding how we can best use automation, And those teams, when you empower them and you put bright people together, oftentimes they produce expansive results. They grow our capabilities. And they certainly develop best practices that we use throughout the organization. Another way to understand the data science value chain is to consider a typical data science project. For us, a typical project, and I'm talking about a big project here, not necessarily something that's small and ad hoc. You're doing something that's going to add substantial value, and there's a lot of complexity in it. So for us, it starts with solution engineering, where you combine the opportunity that you have in the business with your data knowledge and with your business understanding to craft a plan for how you're going to achieve that or deal with that opportunity. Model development is the second stage, and that's pretty straightforward, right? So we're wrangling the data together, using it to create a model. And then the third stage for us is deployment. And oftentimes in data science, that's overlooked, but it's a critical stage. If you don't deploy, you don't drive value. And so deployment is very important for us. So the hypothetical data scientist that I talked about before that sits at the middle of that Venn diagram that I showed, and who's also skilled at this entire series of project management steps, that person is a really big unicorn, right? And so you really aren't going to find many of those. So the challenge is, what do we do in that situation? So this is really where automation comes in for us. Automation like DataRobot really, again, helps us cut through this series of processes. It expands the scope of the projects that we can take on with a positive ROI, because that efficiency allows us to do some things today that yesterday we could not do. Model development is revolutionized in some ways with these automated machine learning tools. So if it's a use case that aligns to using DataRobot, our data scientists can shave months off of the timeline. And oftentimes they're generating more accurate models than they could have had they devoted those months to the process simply by using DataRobot. And then finally, model deployment is standardized. So when we use a tool, a single tool like DataRobot, the deployment comes out in a standardized code that we can then quite easily put into production. In addition to that, we add our own value. So the Enable the Science team at 8451 has innovated our own custom packages in R and Python. We have very skilled data scientists who write these core packages for us. And just as an example, we developed a package that we call SparkBot, which is the second hex here. And SparkBot allows our data scientists to build a model in DataRobot, and then with a few lines of code to deploy that in a Spark environment where we can score hundreds of billions of records very efficiently. So what used to be, again, oftentimes months for deployment, we've turned into days or hours sometimes. In total, this helps us build little unicorns. We can't chase the big ones, but we can certainly make our data scientists full stack. And that means a data scientist is now capable of doing all of those steps, solution engineering, model development, model deployment, without turning to the rest of the organization. And that's an incredible efficiency gain for us. Now, I don't want to slight our engineering team that makes all of this capability possible. They're there. We just don't have to call on them on a day-to-day basis like we would have in the past. Okay, so what do I want to leave you with? First, automation is here. For businesses like Kroger with many use cases that align to the need for predictive modeling, there's already a high ROI for using automated machine learning tools. And we expect that this space will continue to evolve, and very shortly, if it's not there already, it's going to be table stakes for big businesses like ours. Automation, the second point is that automation will not replace your data scientists, right? Instead, you should expect more from them. This is a tool that should allow your data scientists to be more effective, more efficient, drive higher ROI for the use cases that make sense for data science. And then finally, the companies that find ways to re-engineer their value stream at the core and to most efficiently embed this new powerful technology instead of to simply replace old with new, those are the companies that are going to win. And so I challenge those of you who have the responsibility to think about how you use this powerful technology to remember what happened in those early days of electricity, right? You don't want to be the company that got innovated over and above. You want to be the one doing the driving.